So, good evening, everyone. Today we're going to talk about our project, Lore Storytelling Machine, which is a language model that generates a description for character backstories in a game RimWorld. So, as you can see here, everything in this orange box altogether is called a backstory. It has three components: a title, skill modifiers, and a description. So, so the description is what we are trying to generate. So more specifically, our model is supposed to meet four goals. First, it will generate a description based on the title given, and secondly, it will generate different descriptions based on the different skill modifiers. And three, it should adhere to the linguistic style of RimWorld. And the fourth, and most importantly, it should not conflict with the lore and the world setting of the game. So why do we need such a story, such a model? You might be wondering. This seems like a very simple task. Well, we brought up this project because writing backstories, writing descriptions for backstories manually is very labor intensive. And if we use a chatbot like ChatGPT to do it, then it might be very factually inaccurate. It might blend in the elements of other games into our description, which will make it break the immersion. So we are trying to find a compromise. So as everyone knows, if we want to train a language model, you need data. So where would our data come from? Well, our data is taken from the files of the game RimWorld and its downloadable content, or DLC, and several mods. In total, we have collected 2,073 backstories. Now, for data pre-processing, we extracted the parts that we are interested in from the XML files and compiled them into a pandas data frame and that are stored in our computer. As you can see here, there are two words that are enclosed in square brackets called pawn name def and pawn possessive. We will talk about that later. We tried to use these. We tried to add these special tokens into our tokenizer, but it didn't work out so well. So during training, we split the data into a 90-10 train test bit, and we compiled the title, skill modifiers, and descriptions into a training instance or a sentence with the format. This is the story of pawn name def, a title, and then skill modifiers, and then colon descriptions. And we fine-tuned our model based on this training process, and we ended the training process once there's more than 2 epochs where test loss increased in the past 5 epochs. And when generating the backstories, we used a similar structure, but instead of using the whole sentence that consists of titles, skill modifiers, and description, we only use the title and skill modifiers, and then we let our fine-tuned GPT-2 model to generate the rest. And in terms of the software we used, since we only use standard machine learning softwares like PyTorch and NumPy and Pandas, so we're not going to emphasize on that.
Okay, thank you, Colin. So let's see the quantitative resource. Where in our project, we use the test loss as the quantitative resource, and we choose from different learning rates, batch size, and the optimizers. Where for the learning rates, they do not have very big impact to our loss, and all the loss is around 1.25. And for the batch size, the 16 turned out to be the best one. And for the optimizer, the XMW is proven to be the best optimizer for the big model like GPT, which have very deep layers. And for the qualitative resource, we use the GPT-2 large model as our baseline model, and we use the 5 matrix here as our new criterion. And for testing process, we choose 100 examples from all the testing data sets, and we just see whether it meets our criterion one by one. And the results show that a great improvement has been achieved in our model, fine-tuned GPT model, which our parameters is 7 times less than the GPT-2 large model. But for the results showcase, we use the user. We also developed the user interface by Gradio, and this is the basic outline layout of the interface. where the users have to input the character title, character name, and also the character gender. We apply a drop-down box which includes 10 attributes, or we can say the skills of the character, and the value of it can be also adjusted by the users ranging from 0 to 10. So let's see two showcases, where for the first one, we give the architect the skills like the construction and social. So it turns out that it outputs he constructed the building and communicate with the builder. So that's really the thing we want. And the second case, we give the bus driver the skills like the driving and intellectual. So the output is also pretty good. For the future improvements, we hope to extend the description length and to make our description more creative, since we believe that the description can output more details of the character. And also for the skill modifier fuzziness, we have to fix it because it's very hard. It's hard for the models to differentiate, and the special token is not well handled somehow. So this is all the improvements we want to make in the future. And thank you, everyone.